Hey everybody, welcome to today's Kubernetes Master Class. Really happy to have you all on the line. We have just a massive number of registrants for today and quite a lot of people online for today. So wherever you are, welcome. We are going to be talking RKE under the hood. We have a lot to show off and discuss. This is very much meant to be interactive with Q&A. So I'm going to go ahead and jump right in. Just to let you all know right before we get started that this session is being recorded and you will receive a recording and the slides after the training. So if you need to hop off, don't worry about it. We will email you the recording and the slides afterward. Way of introduction, my name is Matthew Shear. I'm marketing manager here at Rancher. I included my email address because if you need to get in touch, find any resource, please reach out to me. I'm happy to help you out, help you find what you need, or you can find me on Slack. I'm just Matthew on slack.rancher.io, so you can find me there. But the people who are going to be doing the heavy lifting and the main work on this call today are Hussein and Sebastiaan. Are you guys on the line?
Yep.
Yes, sir. How's it going?
Hey, all right, awesome. Okay, well, I will let them introduce themselves a little bit more as we go on, but they will be doing the presentation and answering most of the questions today. Just a couple housekeeping items before we really dive in. So we usually do about 40-45 minutes for content, but I think today we're gonna go, I have 90 minutes scheduled for today, so I think we're gonna go long because there's just so much to cover here. We will have time for Q&A too, but like I said, this session is recorded, so if you do need to hop off, don't worry about it. We try to answer every single question that is answered. Just go ahead and put it into the chat and we will get to it as we can. We do our best to answer questions aloud for the benefit of everyone, but if for whatever reason you want it to be just a private question, just mark it as such. That way we will just answer it directly in the chat to you. And like I said, the session is being recorded. All of our other classes, online classes, intro trainings, online meetups, other master classes, they're all on YouTube, totally free. Check them out. It's a ton of fantastic resources. And we post these here every time we do a class. So these will be here as well. And they will also be emailed to you after the session. And if you want to get more plugged in to the Rancher community and ask more questions, go to slack.rancher.io. We also have a channel just for the masterclass series, which is Pound Masterclass, and you can get announcements. We sometimes post files there too if there is like a manifest or some sort of GitHub file that the presenter used, we'll post it there. So feel free to join that if you'd like. Finally, the last pitch before we really get going, we have fantastic classes coming up this week and next. Tomorrow we have our monthly online meetup, which will cover K3S GA, which went GA last month, and Rio Beta. So those should be really good. We have a ton of presenters on that call tomorrow, so that'll be really fun. It's our monthly online meetup, and it's meant to be kind of a community gathering. And then the following week is the Kubernetes Master Class, just focusing on getting K3S into production. So high value, high availability K3S. So it should be really good. Check that out as well. So with all of that out of the way, I am going to pass this presentation off to Hussein, and he can get into the meat of the material. So let me find your name, Hussein, among all of these presenters. Okay, all these attendees, here we go. All right. Making you the presenter.
Can you hear me now?
Yeah, I can see your screen. You're good to go.
Awesome. Okay, so let me introduce myself first. I'm Hussein Galal, software engineer at Rancher Labs. I'm one of the maintainers and contributors to RKE and K3S. Today, I'm going to present some maybe new information about RKE, how RKE works, what happens under the hood, how is RKE designed, and other topics. So basically, this session will cover the following: an introduction to RKE. If you don't know anything about RKE, I will give a quick introduction to RKE and how it works, how to run commands with RKE. After that, I will move to RKE design and how RKE is designed and what are the main building blocks of RKE. After that, we'll discuss how the cluster provisioning works and what is exactly the workflow of the cluster provisioning. And finally, my part of the presentation will end with the RKE reconciliation loop and what happens when you add or remove a node. After that, I will hand the presentation to Sebastiaan, which he will discuss how Rancher and RKE communication works. So my main part will discuss how RKE CLI works and how the tool actually designed. So let's jump right into it. So first of all, what is RKE? So RKE is a CNCF certified Kubernetes distribution, which means it runs a Kubernetes distribution on the nodes specified in your configuration. It runs Kubernetes entirely into Docker containers, so each component is a Docker container running on the node. It works also on bare metal and virtualized servers. All you need to run RKE on your nodes or make RKE install Kubernetes on your nodes is SSH connection to your nodes and Docker to be installed on the nodes. So RKE is just a CLI tool, and or RKE CLI is just a tool that uses a cluster YAML config file to define the Kubernetes cluster. So basically, the cluster YAML or the file that we'll see in a minute is just a file that represents a cluster configuration. Each cluster YAML file represents a separate Kubernetes cluster. So when you run something like RKE up, which we'll see, it uses this cluster YAML to get the node information and install the cluster according to the specs defined in this file. So here is an example of the cluster YAML file. This is a really simplified version of cluster YAML file, which consists of nodes and a list of nodes that you want Kubernetes to be installed on. So here we have only one node. We define its address, we define its role, and user and host name override. So I will explain the cluster config file in details in the few next slides. But right now, let's see quickly how we're getting started with RKE. So right now, just to confirm, Matthew, can you see my terminal screen?
Let me see. Yes, it looks good, and the font looks good too.
Awesome. Okay, so right now we have a cluster YAML file, which only consists of one node. This is a node of the address. I gave the node name node1 and user Ubuntu. This user is the SSH user that I will connect to the nodes with, and I define the role of this node. So right now we define this node as a control plane node and a worker and also etcd. I will explain each nomenclature of these roles and what it represents exactly. So just to start, I installed the RKE beforehand on this machine. So if I did RKE version, this is RKE version 1.0, and when I do RKE up and point to the cluster YAML file, it just starts installing on the nodes. As you can see, it generates certificates and start building the Kubernetes cluster. So it's as simple as that. After you run it will deploy a kubeconfig file so that you can manage your cluster, also deploy something called RKE state file, also in a few slides. So to move on, let's talk about this cluster YAML file, or the RKE config file. So as we saw here, we have the cluster YAML file is just a YAML file that consists of nodes and can consist also of something called services and another few options. So how to get all options for the RKE YAML file? You can use something called RKE and the configuration file. The RKE config is a multi-purpose command. It can be used to generate a new config file. It can be used to present all the options in the YAML file. So for example, if we want like an empty file, RKE YAML file, we can use something like empty, and we print it on the screen. So we will get a YAML file that contain each and every option that can be used inside the RKE cluster YAML. So you can use that and the only required field that you need to add to run the RKE is just nodes. So the field consists of a list of nodes that you want to install RKE on. So as we saw here, RKE finished its job. It's in about 2 minutes. It installed Kubernetes on the nodes. You can use kubeconfig to just point to the kubeconfig installed in the cluster and run kubectl get nodes, and you'll see that the Kubernetes has been installed on the node. So yeah, let's wait for it. Yeah. So as you can see, installed Kubernetes on this node, and so yeah, this delay is just my connection to the cluster. However, let's discuss some building blocks of this configuration file. As we can see here, we have the nodes, we have services.
Hussein,
Yeah.
This is Matthew. Just want to interrupt you for a second. Just because some people have pointed out that when you seem to do something intensive, your voice breaks up a little bit. And so just want everybody to know that we hear it too. And so Hussein, just to the best of your ability, if whenever you're running a script or anything, if you could just slow down a little bit, that might help with the voice distortion. But otherwise, we'll just keep going and do our best. Thank you so much.
Yeah, so no problem. So let me recap what I did so that if my voice dropped in the middle of something. So what I did is just run RKE on a single node. It's a single node cluster. I have the single node defined in the cluster YAML. As you can see here, it's only one node. It has a role control plane worker and etcd, and I run RKE on this node using RKE up. So that's what I did basically. What happened is RKE connected to this node and installed the components, and that's what all the presentation is all about. I will explain how RKE does that, how it connects to the node, how it installs the Kubernetes on each node it connects to. But first, I wanted to explain how cluster YAML is built. What is the cluster YAML? As you can see here, this is a simple cluster YAML that only contain nodes, but to view a full version of the cluster YAML, you can use a command called RKE config, which RKE config print an empty cluster YAML file for your usage. It can be viewed by using RKE config -empty, which will generate an empty config cluster YAML, and you can just print it on the screen, as you can see here. So this is a full cluster YAML file. I will discuss, explain what each building block means. Basically, the main. Let's start with what actually the cluster YAML file is. So we said that the cluster YAML file is called RKE config. It's a configuration file defined by default and is called the cluster YAML file. It can be generated using RKE config as we discussed. So each block of the cluster YAML file contains information about different things in your cluster. For example, the first block is nodes, and we saw that it's a list of nodes that Kubernetes will be installed on. The second block is services, which explains how the components or Kubernetes components will be installed in your cluster. This includes information about different Kubernetes components, including kube API server, etcd, controller, scheduler, kubelet, kubeproxy, and so on. So what happened when you finish installation and run RKE up? RKE up installs something called cluster RKE state file into the same directory that you ran RKE from. So for example, we just started a cluster on a single node. If we list the content of the directory that we started RKE from, we will see that we have a cluster YAML file, we have kubeconfig file that has been deployed to communicate with the cluster, and finally we have something called cluster RKE state file. So the cluster RKE state file is just how RKE keeps track of the state of the cluster, so that if you want to install a new node or remove a new node or add any configuration option to the cluster, it knows what the state of the cluster right now and what needs to be done. So let's take a closer look on the cluster RKE state file. As we can see here, it's a JSON file that contains different information about this cluster. To be edited by the user. It's just RKE uses this file and edit this file every time it runs RKE up or RKE init. So as you can see, it's built from two building blocks, or it generates two main items. The first one called desired state, and the second one is called a current state. So what does that mean exactly? So state file, the desired state represents the state of the cluster that should be in. So basically, it's a translation of the cluster YAML file. So if you define a single node in the cluster YAML file, this will be translated into a desired state. After you finish RKE up, RKE writes the current state, which is the actual cluster of the state, the actual state of the cluster. Sorry. So both current and desired state consists of RKE config and the certificate bundle that has been installed. So to recap, that desired state is populated by RKE from the cluster YAML during the provisioning workflow, and we'll see that in a minute. On each RKE run, it tries to bring the cluster to match the desired state, and that when it succeeds, it writes the current state. Okay, so to recap what we said, we have the cluster state file, which consists of desired state, current state. Each desired state consists of RKE config and certificate bundle, and the current state consists of the same thing. So when the user edits the cluster YAML, for example, to add a new node, RKE will update the desired state with this new node info, and when it finishes RKE up, it will updates the current state. So before moving on, I will check some questions regarding this part. So is there a way to pull the running config from a cluster that was provisioned with RKE? Yeah, that's a good question. So we only write the cluster state file into config map in the cluster after we finish installation. So if we, for example, check kubectl get config map and in kube system namespace and grep for state, we will see that we have a config map of the full cluster state that has been deployed in your system. But this is not meant to be used by RKE. It's just a backup that we deploy on the cluster. So yeah, so thank you for this question. Let me see another question. Is RKE using kubeadmin in the background? So no, we don't use kubeadmin. We use our own installation provisioning workflow. It's written in Golang, and you can check it out on the GitHub. Can we use RKE in air-gapped environment as Rancher? So RKE is one of the distributions that Rancher actually run. So yes, you can use RKE in an air-gapped environment. I believe there is is a documentation page written for specifically for air-gapped. So yeah, let me take final question. Alexi said, can I get RKE config file from existing VMware Rancher cluster? Also, I'm not really clear about that I understand the question, but if you talk about running getting the configuration file from Rancher, you can get that from edit as YAML and see the full configuration file is the same as the cluster YAML, which is being used by Rancher in the background. So yeah, let's move on into one of the building blocks of the cluster YAML file, which is nodes. Nodes represents what are the nodes that will be used to deploy Kubernetes. For example, in this configuration file that we used one node. So what happened by RKE to actually connect to the node? So we discussed earlier that the requirements to connect to install Kubernetes on nodes is SSH and Docker. So what happened exactly is RKE connects via SSH to each node, and to run the containers, it uses SSH tunneling or SSH port forwarding to connects to the Docker socket on the nodes. So we had the option to, we had the option to connect to the Docker daemon on each node by allowing the Docker to listen to the TCP port, but this proved to be a really complicated way for the users to getting started quickly with RKE. It requires the user to log into each node and configure each node with the TCP port, and also make sure that connection is secured by using TLS via the SSH certificates, but we chose to use SSH to tunnel to each node, and then use the port forwarding feature to connect to the Docker socket on each node. So this is what happened exactly. SSH tunnels to each node, and then it uses SSH forwarding to connect to the Docker socket on this node. After that, it runs Docker containers on the nodes, the components of Kubernetes cluster that we will see in a minute. So for the we didn't only specify SSH to connect to the nodes, but we allowed anyone who uses RKE library to define his own connection method to connect to the Docker socket on the nodes. So basically, we use, as I discussed, SSH tunneling to connect to the Docker socket. But if you choose to use RKE library in your own project, on your own tool, you can use different methods to connect to the Docker using service port or any other method you prefer. So we have also different modes for RKE CLI. We have RKE local and RKE Docker in Docker. The RKE local deploys the Kubernetes components locally on the machine, and RKE Docker in Docker works by creating a different Docker containers and specify them as nodes and deploy Kubernetes components within this Docker container. So it's a Docker in Docker method. So this is the first part of the RKE config file. The second part is services. So what actually we deploy on the nodes. So we categorized the containers that we deploy into three main planes. The first one is etcd plane, which consists of etcd container. The control plane, which consists of the kube API server, the kube controller manager, and finally the kube scheduler. We also defined worker plane, which consists of kube proxy and kubelet. But as you may notice that we have also kubelet and kube proxy in etcd and control plane nodes, because we wanted to list the nodes as Kubernetes nodes as well. So not only you see the worker nodes in your Kubernetes, you can see the control plane and etcd nodes when you run kubectl get nodes, but we don't allow scheduling for control plane or etcd nodes. We only allow scheduling for worker nodes. So if the node is specified as worker, we can see that pods are being scheduled on the nodes. We also have or run a specific services to help with that provisioning workflow. You may notice them on the node. Let's take a look on the node that we just deployed. If we SH to the node, you can see that when you do docker ps, you can see different containers that has been deployed. You can also called RKE tools. If you docker ps and grep for RKE tools, we'll see that the RKE tools image is being used as something called a service sidekick. The service sidekick is just a container that runs on each node that contains some files that will help with the installation of the component. Meaning that, for example, kubelet to start, it mounts the files in this service sidekick and then runs the files in the service sidekick. So to take a look at what are the files presented in this container, you can see RKE component. So you can see if kubelet, for example, started, it runs some commands to configure before running kubelet. And
Hey Hussein.
And the same thing goes for other components.
This is Matthew. Hey,
Yep.
just gonna interrupt you because the distortion, the audio distortion was pretty bad when you switched from your terminal to the Google Chrome. So could you just repeat what you just said for people?
Yeah, sorry. So I'm discussing RKE tools, or I'm saying that we install three different planes in RKE: the etcd plane, the control plane, and finally the worker plane. We also install, we run some containers that help with the provisioning workflow. It includes a sidekick container, port check, some containers used for snapshots, and for certificate installation, and for file deployment. These helper services are all defined by a repo called RKE tools. The RKE tools is just a container that contains some scripts and some files that are being used by these containers to deploy different services and deploy different helper files used by the actual components of Kubernetes. So moving on to versioning. So basically, RKE defines different Kubernetes versions for each of its releases. For example, for RKE 0.31 has 4 current Kubernetes releases that is being used within this RKE release, and each Kubernetes version consists of different images for the system. So, for example, we have RKE version 0.31, which has 4 Kubernetes version 113, 115, 114, 116. And for example, if we take a look into 115, we will see that it has different version for each system image. Like core HCD has version 3.310, and Hypercube is 115, obviously, and it has a specific image for the network add-ons and the DNS add-ons and so on. So how is this being actually mapped? It's mapped in a repo called container driver metadata. This repository maps different RKE version with Kubernetes version and with system image versions. So it's also open source. You can check it out and see how the mapping works inside each RKE version. But basically, if you want to know quickly what version you want to use, you can use the command RKE config-l-a, which abbreviation for list versions in all modes. You can see the Kubernetes versions that are being supported. So how can I define or specify a specific version for Kubernetes to be installed on my system? I can go to the RKE config here. Yeah. If I list my cluster YAML file, I'm just going to check with you, Matthew. Can you hear me now? Just I switched to the terminal.
Yes, I can hear you.
Cool. So we have nodes, which defines the nodes as we discussed. To specify a specific version for your Kubernetes, you can use the option Kubernetes version and just write the version that you want. So how to know actually what version that I need to use? As we said, we can use RKE config-l-a, and it will list all the Kubernetes version that are available. So you can just copy one of these and paste it in the cluster YAML file, and it will install the corresponding Kubernetes version on your nodes. So if you do kubectl get nodes, you'll see that by default it installs a specific version. To know the specific version that is being used, you can use RKE config-l only. It will list the current or default version that it is installed on your machines using this release of RKE. So this is how versioning works in RKE. So before moving into provisioning workflow and reconciliation, I'll take a few more questions. So Raj asks, can clusters provisioned by older versions RKE that didn't have the cluster RKE state by adopting the new RKE? Okay, so this is a good question. We used to have a different method to storing the state of the cluster. We used to store the state into Kubernetes cluster as a secret, but we don't do that right now because storing the state on the cluster and on the nodes proved to be somehow inconsistent when adding or removing nodes. But we upgraded to the new method that I'm explaining right now, the RKE state method. If you run RKE with the new version on an older cluster, it will upgrade the older cluster to using and use the new methodology of deploying the RKE state. So yeah, the upgrade works from older version to the newer versions. I'm taking another question. Andres say that can we recreate the RKE state file if we don't have it? Yeah, as I explained, we store the RKE state file in a config map in the Kubernetes cluster. So as long as you can have access to the cluster or etcd, you can construct back the cluster state file. For example, when we get config map, we get cluster full state, and we get in a YAML configuration full cluster state. Yeah, full cluster state, and we get it in the YAML configuration. You can see this is the YAML configuration of the as you can see here, this is the JSON file constructed by Q. Okay.
Hey, Hussein, this is Matthew again. The audio cut out quite a bit just now as you were running those commands in the terminal. Can you just repeat what you said?
Okay, so basically I'm saying that you can complete a file from the config map stored on the cluster using kubectl as I demonstrated in a minute from a minute ago. Another question regarding the RKE setup via SSH connection. I just saw SSH username. Can you use password or key file as well? So basically, we by default we use the RKE. We use the SSH ID RSA key file stored in your home directory, but you can specify different path for the key. Also, you can specify SSH certificate to connect to your machine. Also, if you take a look into the cluster YAML configuration, you will see that we can use also SH authentication to SH agent to specify different password for the keys. But we don't enable by default, or we don't enable the feature of using a password for each node. We only enable connection with keys. So I'm going to answer a final question. Can the state file be stored remotely, like a Terraform state file? No, not really. The state file currently is used on a disk. So there is no way to store it remotely, but we store a backup on it of it on the Kubernetes cluster in a config map, as I discussed. So I'll be moving on, and I apologize for the low bandwidth connection. So what happened when you run RKE up? When running RKE up, it runs something internally called RKE Init, and then runs RKE up. So basically, if you look at the code, you will see that RKE uses two main functions to construct the cluster. One function called cluster init and the other function called the cluster up. The cluster init, which is RKE init, is used to update the desired state of the state file. This is basically saying I want my cluster to be in this state. After that, cluster up compares the current state file with the desired state file, and if it finds a difference, it applies this difference on the cluster and updates the current state with the new state of the cluster. So basically, when you run RKE up init, it translates the cluster YAML to the desired state, and when you run RKE up, it takes this desired state and install it on the nodes and updates the current state. So if we take a further look into how init and up works, so this is a flow chart explaining how actually the code works for cluster init and cluster up. So cluster init reads the current state. If it finds any certificate or if it's a new cluster, it generates the certs. If the certificate is found, if certificates are found, it regenerates any missing certs, and it updates the desired state of the cluster, the desired state of the RKE state file, and writes a new RKE state file. After that, cluster up reads the state file, compare the current state and desired state. It tunnels to the hosts, as we discussed. It deploys the certificates. It reconcile the loop. Reconcile loop means it checks for any added new nodes or removed nodes from the cluster, and we'll talk that in a specific in a minute. And it deploys after that the planes, etcd planes, control planes, and worker planes, and then adds the add-ons and network components to the cluster. So this is how cluster init and cluster up works. So before moving to the final part of my end of presentation, we'll talk about the component authentication, meaning what happens between the components to authenticate with each other. As you may know, that Kubernetes supports different authentication methods between components, including using basic authentication or token files, and of course client certificate authentication, which is X509 authentication. Basically, it uses certificate to it uses a master certificate to verify the client certificate and make sure that the client certificate is actually signed by the CA. So this diagram explains how we manage certificates between the components. So we start the API, and we generate a certificate for each component, including the API. So first we generate a master CA certificate. This master CA certificate then signs different certificates, including the API, controller, scheduler, proxy, kubelet, and etcd. After that, each controller is configured, each component is configured with its own certificate. So the controller has the controller client certificate, which presents to the API. The API then uses the master CA file to verify that this certificate is signed by the CA and accept the connection. If the controller didn't present the right certificate, it will deny the connection or unauthorize the connection. For kubelet, there is a specific special use case for kubelet. We have a kubelet API as well. So kubelet has its own API. So the API server has also to authenticate with kubelet. We also define the kubelet server authentication server certificate, so and sign it by the same master CA. So the API presents its own kube API client certificate, and kubelet will verify this connection as well. So finally, the API itself authenticate with etcd. It presents the node certificate on the node, and etcd will use the master CA to verify this to verify this connection. So to recap, we generate a master CA, we generate a certificate key pair for each service. We also generate etcd certificate for each etcd node. We generate a proxy client for the aggregation layer, and finally we generate a service account key file. So on each run, RKE check if any new node has been added, especially etcd or control plane node, and it regenerate the etcd certificate with this new node to update the sans in this certificate and redeploys the certificate on the nodes. We also allow certificate rotation for your nodes. So if you run RKE cert rotate, it will update the certificates. It will reassign all the certificates and redeploy them on the nodes, and will restart the components corresponding to each node. So finally, I'm going to talk about reconciliation loop and how RKE handles adding or removing a node. So when removing a node, RKE check if this node etcd or any other row. So basically, the etcd has to have a special handling because we need to remove the etcd node from the as a member from the cluster, and then proceed with the normal removal of the node. So basically, we check if the etcd is a member of the cluster. We remove the etcd from the etcd cluster. This is equivalent to running etcd-ctl member remove. After that, we delete the node from Kubernetes cluster. This is equivalent to kubectl delete node. This basically, if you list the nodes in your cluster, you won't find the node. Finally, we clean the Docker containers that we installed on the host. We don't delete the pods that has been installed, so that we only delete the Docker containers that we actually deployed. So if this node happened to be a control plane node or a worker node, however, we just delete the node from the Kubernetes cluster and clean the Docker containers. So to add a new node, RKE check also for the role. If it etcd, it add etcd as a member to the cluster. This is equivalent to etcd-ctl member add, and it runs etcd on the new node. If it's a control plane or worker, it doesn't do anything. It just leave the installation to the rest of the RKE provisioning to install the control plane, etcd plane, and worker plane on the node. So as you can see here, if the current state, if the RKE state file consists of desired state has only one node, when you add another node, you will see that the desired state has a new node being added to the desired state. So yeah, this is my part of the presentation. I'm going to answer a few questions and handle the presentation to Sebastiaan. Follow-up question regarding older RKE to new. Does it also require upgrading the Kubernetes version to make full use of RKE features such as cert rotation? So to use new features in RKE, you need to upgrade RKE itself. But if you want to use RKE rotation on an older cluster, it's still it should still work and will upgrade the certificate rotation. So certificate rotation, for example, works on the older clusters and works on the new cluster as well. So can multiple etcd be removed from RKE or best to do once at a time? Yes, you can remove multiple nodes at once using etcd. This happened by just removing the nodes from the YAML file and running RKE up. The reconciliation loop should figure out what has been removed, and the reconciliation loop will delete them one by one, and it will handle deleting them one by one so that it won't break the cluster. So what is a proper way to upgrade the RKE binary being used for an existing cluster? as this also changed supported Kubernetes version. Should one change desired Kubernetes version to match one supported by the new RKE version? So yeah, this is a good question. So basically, RKE versions works with a corresponding RKE release. So Kubernetes versions, each RKE release has its own versions. So basically, to upgrade RKE, that means that it comes with a new version. However, you can still use the older versions if you specify the Kubernetes version in the cluster YAML file. So if you pin down the version in the cluster YAML file, it will keep using this version and not upgrade to a new version. Does RKE provide the functionality for Kubernetes node authorization? I remember RKE once used for each kubelet the same client certificate and did not support node authorization. Is still the case? Yes, RKE uses one certificate for all the nodes for kubelets, but however, we are in the process of adding of supporting a new feature of using a separate certificate for each kubelet. Can we automate certificate rotation for Kubernetes component by month or a year, for example? I guess you can use RKE command with any configuration management tool to run or automate the running of RKE cert rotate. It's just one command that can be run from a specific directory that has the RKE state file. Can use Helm to install chart in Rancher cluster. So yeah, for RKE you can use you can deploy Helm afterwards and run in Helm version 3. You don't have even to install Tiller. Just you can install charts on your cluster. From in Rancher we have a controller that deploys apps using charts, using Helm charts that you can use directly from the UI. So yeah, I think let's summarize some of the questions. I'm gonna hand over the presentation to Sebastiaan, and sorry again for the low bandwidth of connection. Yeah, thank you.
Sounds good. Thank you, Hussein. All right, let me see. Can you hear me? Can you or Hussein or Matthew confirm that you can hear?
Yep, Sebastiaan, I hear you just fine.
All right. Let's see. And now I'm sharing my screen, so can you confirm that you see my screen?
Yes, sir, I sure can.
All right, then we're getting started. So thank you, Hussein. So what we just heard was Hussein talking about mainly RKE design and using RKE as a CLI, so as a command line interface tool. Of course, we have another product as Rancher Labs, which is called Rancher, our main product. And part of using Rancher as a software to manage and create your Kubernetes clusters is launching, this, like shown on the screen here, is adding clusters. And that means you can either create new clusters or import existing clusters. So let me start by basically what Rancher is management software for your Kubernetes clusters, which can be any Kubernetes clusters. And that means, like I just said, we can create clusters either from your own nodes that you already built using Linux and Docker, or we can create nodes for you on a certain from a certain provider, or obviously you can create a hosted Kubernetes cluster, which one of the main vendors offer. And then besides that, Rancher itself, this talk is not about what Rancher can do, but obviously Rancher offers UI, central authentication, monitoring, logging, service mesh, and many more features. But we're focusing on, in this talk, we're focusing on creating clusters because that is where the relation between Rancher and RKE happens. So the options for clusters that I've shown here, let me just go to the next page. So where Rancher uses RKE to create, but also to manage, which I will explain in later in a later slide, is those two options. So the two options are you have your own Linux nodes, and also in Rancher we have support for Windows nodes, but let's focus on Linux for now. You have your Linux nodes with Docker installed, and those can be added to a custom cluster. That's one option. If you also want Rancher to go to one of these infrastructure providers and create nodes for you, you can also configure that. What happens then is that we will reach out to the APIs of one of these services. We will request a machine based on the specifications that you can configure. So a certain CPU, certain memory, certain amount of disk space, certain instance types, kind of depending on the cloud, the infrastructure provider. And then when we have requested that machine, we will install Docker on that machine. And then when Docker is installed, we will also add it to the cluster. So basically, if you look at the first option, which is the custom from existing nodes option, that is where you bring your own nodes with Docker pre-installed, and we give you a command, and that the command is a Docker run command, where we will run a container on that machine, and then that machine will be added to the cluster in Rancher. And the second option is we will also create the instance or the machine on an infrastructure provider. We will install Docker, and then we will run that command automatically. There are a lot of other handy features for when you're using nodes from an infrastructure provider, because you can easily scale up and down, because there will just be one template which has a configuration, and you can just scale those up as you want. There are a lot of more options. So I would definitely suggest that you check out the documentation on that, because we won't explore all the functionality in there, because that will take a few hours to deep dive into that. This is purely about how are we provisioning clusters using parts of RKE, and not about all the features that we can do within Rancher. But you can definitely check that out. And you can obviously check the documentation or reach out on Slack if you have any questions, or ask them now, obviously, because we'll also answer them now. Okay, so what I wanted to emphasize in this presentation is basically the differences, because the design of RKE, Hussein spoke about that. He explained how RKE was designed, how it was built, and how it will provision clusters. But now we have Rancher, and there are I would say quite a few differences when you create a cluster in Rancher versus creating a cluster in RKE. And I would say one of the main things that are different, obviously, is in RKE, we create a cluster.yaml file, which Hussein discussed. And then based on that configuration, you run RKE, either RKE up straight away, or you can do it in 2 steps, but most people will use RKE up. And then if you want to do anything to your cluster, you have the cluster state file, which is then generated. And then you can change your cluster.yaml with new nodes, or you can remove nodes, or you can change versions, etc. But there's no, and someone already asked that, there's no remote state of that state file. In Rancher, obviously, we do have, Rancher is running somewhere, and Rancher has state. So we can store cluster configuration somewhere. So there's no local file anymore that we depend on. So now we have Rancher, which can store cluster data. So I would say that is one of the main differences. Besides the cluster.yaml for RKE, we also obviously have Rancher specific features. So basically the custom cluster configuration that we can configure is now in Rancher is Rancher options. And then a part of that Rancher cluster configuration is the RKE cluster configuration. So we basically embed the RKE cluster .yaml inside our own Rancher cluster configuration, because Rancher offers certain features which RKE does not have, and those need to be configured. And then inside that Rancher configuration, we embed the RKE cluster .yaml. So basically, I would say anything that you can do in RKE, you can configure in Rancher, right? So there's no, you don't get anything less, but we also need to make sure that you can configure Rancher features. For instance, if you want to configure logging for your cluster, we need to have that configurable for Rancher, but that is not an RKE feature, right? That's something that Rancher adds to your cluster, or gives you the option to install to your cluster, but that's not an option that you can say in RKE cluster.yaml monitoring true, and then you can monitoring, for instance. Same for logging, same for a few of these features. So that's one of the differences. The other difference is kind of what I just also said with the state, is that we now have an option where we can get a command. So that's a Docker run command that I said earlier, where we run a Rancher agent, and then using that Rancher agent, we can dynamically add nodes to a cluster, and that's quite different than having a static cluster with YAML. A lot of people will ask the question, hey, can we use auto-scaling groups? Can we use some sort of scaling using RKE? And that's all not built in. That's all you have to make that yourself. So that means the cluster.yaml obviously can be templated. You can retrieve certain configurations, and then based on available machines or instances, you can generate a cluster.yaml and then run RKE up, for instance. Those are options. We also are in the works, because that was another question, for the Terraform RKE provider, which we are working hard on to get that official. But there are definitely options, but at this time you will need to get some scripting for RKE CLI. For Rancher, you already have that, so we give you a command and you can dynamically basically run commands to nodes and then add them to cluster. Another option another difference that we're going to talk about is the provisioning of the nodes, and that's especially the etcd and control plane nodes. So the etcd and control plane nodes are part of running RKE, basically Rancher, to keep it simple, because there's a lot of in the code, there's a lot of stuff going on, and people that want to dive into that, I have in the next slides, I have a lot of references where you can actually dive into. So feel free to do that, but it's really hard to have a decent presentation and not dive into the code and scroll to code and confuse people. But basically, to describe it, is that the Rancher will run RKE up under the hood, right? RKE up the command to start to run a cluster. But in Rancher, the worker nodes are handled differently. So nodes with only worker, the worker role, are handled by Rancher and not by RKE in this case. So when the cluster provisioning happens in Rancher, only etcd and or control plane nodes will be part of that provisioning process. And then after, workers will provision themselves, and I will explain how that works in a few slides, but that's a major difference. Obviously, the cluster provisioning reconcile is handled by Rancher, so we are not running RKE up on the command line, but it's handled by Rancher, and we will talk about it too. And another difference is the etcd snapshots. So the etcd rolling snapshot container in RKE is deployed to handle RKE snapshots. That does not exist in Rancher. So in Rancher, we have functionality in Rancher itself to handle those backups, because first of all, they need to be stored in the API. They need to be accessible for Rancher. Like I said, we have state there, so we can actually store information. And that's another thing. Because RKE doesn't have any state somewhere that we can store, for instance, that we can store, hey, we have those backups. They will be on the nodes themselves, right? So we will go over all these. So these are the main differences that I want to point out. We'll go over them in detail, and then we'll go from there. I think these are the main differences that you should know when you work with RKE and Rancher. All right, so the cluster options. What I said before is the cluster options in Rancher are a part of adding a cluster. So if I go to the add cluster screen that you see screenshot below, is we add a custom cluster. You can give it a name, and then you have an option here, cluster options, where in the UI all the options, and then those can be both in the UI, both Rancher and RKE options are provided. And we also have an edit as YAML option where you can basically use a YAML file because people want to standardize or export or keep your cluster configuration in a structured file, which makes sense because it's easier to diff to see the difference in the file. It's easier to automate. So I mean that all makes sense. So if you go into that cluster options YAML. So if you look on the right here, it says cluster options and then Kubernetes options, and this is the editors YAML view. You can basically see that those options here, which what I was talking about before, those are Rancher options, right? And then here you see Rancher _ Kubernetes _ engine _ config. This is, if you look like to people familiar with RKE will recognize those keys, key names, and those are basically, this is basically the cluster.yaml from RKE, right? So these are options because, like I said, the options that Rancher provides you, you also want to make configurable, obviously, because people need to be able to configure this. But if you want to configure anything with your clusters, you can use your cluster.yaml as is inside Rancher. The only part to clarify that, obviously the nodes part is not part of this Kubernetes engine config, right? So the cluster.yaml, where you define the nodes and how to connect to them with the addresses, etc., those are not included here because that is what Rancher does under the hood, where we add nodes using either Docker run or the nodes from an infrastructure provider, and then based on that we will basically, I would say, merge the node information from Rancher, so the nodes that are added to the Rancher custom cluster, use those nodes to apply this config. That's how you can see it. But these are all the cluster related configurations, right? So besides the nodes, you can use your cluster.yaml, your RKE config, cluster config in here. Okay. All right, so okay, let me just do a few questions because we've done the intro and some other things. Let's see. Integrate. Okay, I see a mix of RKE and Rancher, like RKE CLI questions will. Yeah, I see a lot of questions. I don't see anything directly related to this. Let me see the. I would say, is it possible to deactivate the possibility to create a cluster using the Rancher UI? We would like to have it read only and force our users to use the API Terraform. So there is a authentication / authorization model in Rancher. I think you're asking for read only. So there's a read only role. I can remember that there was something that someone was always able to create a cluster, but I think in the latest version that shouldn't be available anymore. But for the person that's asking that, please reach out to me on Slack, or I will so that I can contact you to look it up. But there is basically an RBAC model where you can create users and then assign them roles, and those roles are read only. And like I said, I think in the beginning there was an option, or basically besides what you configured, they could always create a cluster, but I think that was removed in the most recent versions. But I'll have to look that. I'll have to look it up. Okay, and there's another question here, which is I would say asked a lot, is that will RKE support using controllers, and that is Nginx Ingress, for instance, built directly from Kubernetes source code rather than through Rancher forks? So that's a good question because the Nginx Ingress is indeed a fork version, and that also means that we have to manually trigger a new release from Nginx Ingress based on things that we need to add because Rancher interacts with the Nginx Ingress controller based on APIs that Rancher can use to provide information in the UI. There are certain commits that we have in our fork that make certain functionality available. So do we officially support it? No, because we give you a set of images and a set of versions, and that also means that we tested that. So no, if you run or compile your own versions, even if it's the Kubernetes upstream, that's not something we tested. We are looking into, I mean, we always strive to not use those forks / other commits, because not only does it delay versions, but also yeah, it's just not something you want, right? We basically we aim for upstream. If not possible, then we try to update as soon as possible. But sometimes it's tricky if you read certain functionality, even if you want to upstream your code to the project, because it still needs to get in. So I hope that answers your question. But we are, I mean, like I said, we always are looking for better options, because it's for everyone better to have the latest release versions of components. So, all right, let me continue on with the next step, and that's dynamically adding nodes to a cluster. So basically, when you create a cluster, I'm just showing you relevant parts of the UI in this presentation, because I can go to the UI, but basically when you start Rancher and you add a cluster, you get all those screens, so we don't have to go to each screen. This is the part that you get when you create a custom cluster. You get the option to assign a role, obviously. So these are basically correspondent to the planes that Hussein explained. So the XCD plane, control plane, and the worker plane. And based on those roles, they will be added to this command, right? So if you select control plane XCD, those flags will be added. This is the command that you get when you add a custom cluster. So to reiterate, when you create nodes from an infrastructure provider, this is the command that will automatically be run on that machine, right? So after that we install Docker for you on that node, we will run this command, and then it will get added to the cluster. So that's basically what is automated. Maybe I forgot to mention, this is a really good option for users that already have their Linux provisioning set up, and they just want to say, hey, I want to hook this up into Rancher, give me a command so I can edit. This is your command, right? And this is all, I'm not sure if I mentioned that as well, is that everything in the UI is API driven, right? So this command can be retrieved using the API, and we also have a CLI, so you can script automate all of this. So you get this command where we basically point, so it's a Rancher agent, which is good to clarify. So we have an agent which talks to the server, obviously Rancher itself. We point it to a server, we give it a token for authentication, and we have a CA checksum because this setup was using a self-signed certificate. You don't need a CA checksum if you have a valid certificate, so that will not be there. And then we put in a role. We have advanced options where you can explicitly specify what address and internal address you have to use. Those are basically correspondent to the node address and internal address that Hussein explained in the cluster.yaml. So you can see the relation where Rancher gives you functionality which is based on RKE, right? So certain options are exposed to either the UI or a command where those flags correspond with the cluster configuration of RKE. That's why I included the link, so these slides will be available later. I included the link so you can look it up. All the options for the agents are there. So go check that out. It's way too long and way too many options to all explain, and it mostly are not relevant because, like I said, IP addresses, roles, flags, I think taints and labels, you know, all those things. If you want to register a node with a label, you can do that on the command line. Okay, so another thing that we discussed or that Hussein discussed was the ability to connect to a node using SSH. Obviously, in Rancher, there is no SSH connection, so basically the agent is the connectivity or basically entry point for Rancher to the node. So what happens is the agent runs, connects to Rancher, sets up a WebSocket connection, and then Rancher can use that connection to contact the node and also contact the Docker socket that it needs to run all the RKE options, right? So the whole SSH option in, like, when you're running the custom cluster with a Docker run is the agent, which kind of makes sense because you give us a node and we don't have anything else to that node than the agent, right? We don't have your SSH keys, we don't have anything that you provisioned it with. It's Rancher reaching out, or basically that node reaching out to Rancher, hey, I'm a new node, I want to be added to this cluster. And then it sets up a connection, and then Rancher can use that connection to, run actions, run certain things. So if you upgrade Kubernetes, then if RKE in Rancher wants to upgrade the Kubernetes versions on the node, it can use that connection. Okay, so the second step is after that is done, so after the provisioning has been completed, because then all the Kubernetes components are running on a node, just like Hussein showed with the Docker PS on his terminal. You can see all the Kubernetes components being provisioned, being deployed, Kubernetes is running, and that means that based on the role, obviously, let's say you configured all roles, that etcd, the kube API server, the kubelet, basically all the Kubernetes components are running, and that also means that we have the node agent as a daemon set pod, which then will be spawned, right? So the kettle node agent is also running in the cluster as a daemon set, or not also, it's running as a daemon set pod on every node, obviously, because it's a daemon set. And then that node agent that is managed by the cluster will remove any manually run Docker run agents, because it will then be part of the cluster, and the cluster will be able to make sure that the pod stays alive, right? So even if you reboot the cluster or whatever, the Kubernetes components will still be there, and they will start up. And then if the kubelet successfully starts and registers itself to the kube API server, then it will also revive those pods and make sure that they run again, which will restore the agent to the server. More information about the kettle node agent daemon set on how that is configured and how that works. I provided the link there. We also have a cluster agent, which is for Rancher the way to connect to the cluster. So next to the kettle node agent, we also have a kettle cluster agent, which will then be the entry point to the cluster for Rancher to connect. So where the kettle node agent is the pod, or the entry point for the node, is the cluster agent the entry point for the cluster. That's also explained on this documentation page. This is not strictly a Rancher RKE adding a node to a custom cluster is not strictly related to that. So that's why I just left the documentation, because it's basically what I just said. So the cluster agent is used to communicate to the cluster over a tunnel, and it will also fall back. So if the cluster agent does not respond or is not available, it will also fall back to the kettle node agent. But that is all explained in the documentation there, so I would definitely check that out. Okay. I also described I think that I've described most of this already in my previous slide. Is that the agent container, so the Docker run command that we just saw, launches the agent container, runs a shell script as like the entry point. That shell script does, parsing of flags, basically the default things that you get from an entry point shell script that then launches a agent binary. So I'm not sure if that was emphasized before, but both RKE CLI and Rancher are written in Golang. Basically, everything is written in Golang in the language. So that means that in this case, the entry point of the container is a shell script, and that launches the agent binary, which is compiled using Go. So we write everything in Go, and then we compile a binary, and that is then run. And that will then connect to Rancher using the WebSocket connection and do all the logic for the agent, right? So I mainly added this slide for people that, like I said, want to dive into the code. That's why the links are there. So everyone that wants to deep dive, hey, how does this work? Please check out this slide, and please check out the links, because I would say this is like your starting point where you want to see, okay, how does this actually work? Like, how does it actually connect to Rancher? What does Rancher return, and what does the agent do after, and how is the provisioning done? So the provisioning itself we will discuss in a later slide, but these are like the steps of adding a node to the custom cluster. So I would definitely check that out if you want to know more. Like I said, I don't want to open these links in the presentation, because I would say like node scrolling and then for code scrolling and going to functions and whatever, it's not only confusing, but also it's way better to do on your own, and then come back to me or come back to the Slack and say, hey, I've seen this presentation from Sebastiaan, and he's pointed to this code, but I don't see it, and that's fine. Can help me out. That's all good. This is just an entry point for people who want to know. All right. Okay. So that's adding clusters to nodes, right? So we had the two options to create clusters. That is the custom cluster, where we can generate a Docker run command, and that Docker run command launches the agent, the Rancher agent, and that flow that we just described uses that flow that we just described, so the shell script and the binary, and then all the actions to add the node to the cluster. And now the other difference that I mentioned in the beginning was worker nodes. So if let me just check if this is right. Yeah. So what happens in the I'm just going to see. Yeah, I actually want to start with this because I don't want to start with the worker nodes as that is a separate like we haven't talked about the provisioning process of the cluster yet using the etcd and control plane nodes, besides that it is different from workers, but I don't want to discuss the worker nodes before I describe how the actual custom cluster provisioning and reconcile, which Hussein described in the beginning using RKE CLI, works in Rancher. Before I'm going to add like how workers like are an exception to this, because I can't explain what exception is if you don't know what the main thing is. So let me start by using the custom cluster provisioning and reconcile. So every cluster in Rancher, and every cluster meaning all the clusters that I just described. So that means the custom cluster, the cluster with nodes from an infrastructure provider, but also imported cluster and also the hosted Kubernetes clusters all have a certain driver. And if you open a cluster in a Rancher UI and you click on the button on the top right where you can get options like cluster options, and you go to view an API, you will see a driver key which will tell Rancher, hey, this cluster uses a certain driver, and the driver is then the logic of which Rancher can use to know how to do certain actions to that cluster. And that driver refers to container engine. So people who are not familiar with this component, this is a different, not really a project, but it's a repository, so it's a tool. It started out as a CLI tool and a tool that we use in Rancher. It's not that commonly used as a CLI tool, but it can be. But we use container engine to provision clusters. So container engine is basically our library, our project, which we use to provision cluster in Rancher. So if you have a cluster in Rancher, we have a certain driver, and that driver has certain options where we can say, okay, if you want to create a driver or you want to create a cluster using this driver, then it will use the create function, like talking in code, it will use the create function of that driver, right? Makes sense. So if you say, hey, I have a GKE cluster from Google or an EKS cluster from Amazon, if you put a create of that type cluster you want to create, you call the function create, then it'll go to that driver and say, hey, you're asking for a EKS, Amazon EKS cluster, which uses this driver. You call create, then I'm going to execute this code. So it's basically, it's an abstraction, right? So it's container engine, it's a driver, that driver implements certain functionality, and that functionality is provided by the driver. That's basically how that works. So that container engine has drivers which you can use to create, edit, and remove clusters. That makes sense. So these functions in those drivers, so if you go into, so this is the repository that you can open. If you go into container engine drivers, and then on the drivers, you basically see, like I said, EKS, GKE, AKS from Azure, all the options that we can use to create clusters. But also we have an RKE driver, right? Because basically all clusters in Rancher are handled the same way, and that is, okay, we create a cluster, and then we use a certain driver, which is the driver key in the view and API view output, where we can see, okay, anything that needs to happen to this cluster, we can use this driver, right, to make it happen. And that can be an RKE cluster, and in that case, this RKE driver will be used. It can be AKS, it can be GKE, just what I just said. All those options will be available using the driver. The point for me saying this is that to make clear that there's no difference in using or in logic when Rancher provisions a certain hosted cluster or when it uses the RKE driver. It's just an RKE driver is just part of all the other drivers and uses the same functionality. So to create, update, remove, those are the most commonly implemented functions. There are more, but I want to keep it as simple as possible for now. Those options are available in RKE driver, but also in the AKS driver and the EKS driver, depending on what type of driver the cluster is coming. That's basically what I'm saying. Again, those are the reference for the code when you're reviewing this presentation and want to look into, hey, how does this work? This is your main entry point, one of the main entry points, because the second one I'm going to show in the second slide is on how things are called and how the connection between actions in Rancher, so that means creating a cluster, updating a cluster, but also removing a cluster if that's something that you want to dive into. How does that link to certain actions? So if I create a cluster, hey, this create call is at least showing me what functionality is in there, and I can tell you it's quite a lot, because there are a lot of like edge cases, but also a lot of like situations that we need to catch, like when things are not going how we want, because yeah, sometimes state is not really what we expected it to be. But this is one entry point, and the second one are the controllers. So Kubernetes controllers, for people who are not familiar with it, is Kubernetes controllers are a thing on their own, right? So it's not that Rancher invented Kubernetes controllers or anything. It's Kubernetes has controllers, and Rancher uses or makes extensive use of controllers because those are, like I described on the second line, are control loops that watch a certain state and then you can act upon them. So certain resources in Kubernetes, you can watch what happens with that, and then based on that you can act upon them. So for instance, and this should be relatable to what Hussein explained about RKE, you have a certain you observe a certain state and you have a desired state, you can act upon it to say, hey, now I want to kick off, you know, for instance, so simply said, hey, I'm changing a custom cluster from Kubernetes 1.14 to 1.15. I submit that code. Then the controller can watch a certain event or watch a certain resource. So for instance, a cluster resource. Hey, there's something changed. Hey, I'm going to compare, because something changed, I'm going to compare the previous configuration and the desired configuration, and then we can apply the changes, right? So for instance, like I said, 1.14 is the current state. We want 1.15, and then we can act upon that. That's basically how, how in the majority controllers work. If you go again, if you go into the code that you can use to see, hey, what does Rancher use controller-wise, you can basically go to package controllers management. At least I would start with the management controllers, because we also have users controllers, and then we have a cluster provisioning, and then in here we have a cluster provisioning controller, which basically is that control loop, right? So that runs in Rancher and it's going to watch the resources and make sure that in this case, let's start by, hey, we created a cluster, we added a node, something changed in that cluster because we added a node, and then we can kick off a provision. And if we add another node, then we need to reconcile, right? Because then we need to put that reconcile logic that Hussein explained about running RKE up with a changed cluster.yaml. Like I said in the beginning, we have the configuration, we have the cluster.yaml partly embedded in, or basically completely embedded into the Rancher configuration. Then we have the nodes, which is not part of the YAML, but that's something that Rancher stores, right? So we have the nodes available that we are adding through a Docker run command or using the infrastructure nodes. And then we use that information to see, hey, the cluster is being changed, or there's a new node, and we trigger something to make sure that the state is brought into the state that we wanted. So that cluster, we didn't go through all the cluster configuration, but let's say you said, hey, I wanted a cluster, a Kubernetes cluster version 1.16 with those extra arguments to the kubelet and with this extra volume mount and whatever options you said. Then this will kick off the provisioning, and that provisioning will then use RKE. So like I said, I didn't really want to embed any code on screen. I just want to put the links in here where you can see where the functions. So some functions in RKE, for instance, RKE up, so the function that makes RKE up work is referenced in this code, where you can see, hey, this cluster provisioner now calls, because that's how the flow is. The cluster provisioning calls the driver. So we talked about the driver in the previous slide, the RKE driver, and that can either be create or update or or delete. There are more functionality, but let's keep it with those 3 functions. So if I update my cluster, then the driver will call, or the driver update will be called, and then that driver update will contain the RKE up command, and that will then be run inside Rancher. So like I said in the beginning, the cluster provisioning / reconcile, which is done by RKE by running RKE up, is done by Rancher using, or I would say using controllers, which is that control loop that watches certain state, and then based on that we can call certain functionality. And in this case, in this simple example, that's the RKE up to make sure that, for instance, either the Kubernetes version changed, or a new node was added, or some other event. The controller will make sure that the driver is called to update the cluster, and then RKE will run to provision the cluster to the right state. Okay, I don't want to take like too much time, so I really want to continue the slides for now, and then just do a few questions at the end, because we're already getting. I mean, it's already quite long, right? With Hussein talking about RKE and me, I can imagine there's a lot of things going on. So let me just finish off the worker nodes and etcd snapshots, which are the last 2 differences between RKE and Rancher, and then we can after go for some questions. So bear with me, please. Okay, so when RKE up is called, so that's the reason why I moved RKE worker nodes to the end, is that when etcd and control plane nodes are provisioned, or when they are added to the cluster, then Rancher, the cluster provisioner controller, so we saw controllers, cluster provisioner controller that watches the state, sees, hey, etcd node gets added, control plane node gets added, okay, let's kick off RKE up, simply said, and provision a cluster. That will not include, that whole provisioning process will not include worker nodes. Worker nodes are treated differently in Rancher. They're not part of that process. Worker nodes are handled by Rancher themselves. And I actually wanted to put a screenshot from this slide, but to show you an example, this is a custom cluster nodes view in Rancher, and you can see the etcd. Let me point it out. You can see the etcd role and the control plane node, which is provisioned, and then sometimes. So this is this is in Rancher terms, this is fine. So these worker nodes, one is still registering, and one is being registered. So this means runtime network not ready. That's just the deployment of the network CNI plugin, which can take a few minutes and then will eventually recover. But the reason why I'm showing this is that normally the cluster provisioning within Rancher will show as provisioning. So you add a node and then it will show provisioning. Just let me get out of here because I actually have a Rancher where I can show that. So if I go, yeah, okay, you can see that. So if I go into this Rancher setup, which I have with those nodes, and I'm just going to edit this cluster real quick, where I'm not really editing anything, but I'm just triggering a provisioning run to show you guys how that looks. So if I go into that edit YAML, which I just showed you as well, and I go into add on job timeout, and I'm just changing this to 31 because I want to trigger a change, right? I want to trigger a change. You can see this cluster goes now into updating state. So normally this updating state for the cluster, and then these lines, people who have used RKE before, this is basically the output from RKE, right? So RKE, if you run RKE on the command line, you will see this output like scrolling by where it says, hey, I'm doing this, etc., etc. This is normally the state of a cluster when you add a node. So the reason why I'm showing this is that if this is an updating state, this only affects the updating of control plane and etcd. Those are included in the plan, you know, the plan that RKE creates to provision a cluster. The workers are excluded from a plan. The workers are handled differently, meaning that the workers also have an agent, and that agent will reach out to Rancher and say, hey, give me my configuration. I will apply it myself. So if I go back to the presentation and I go into this slide, the Rancher agent on a worker node will basically run. It will register, so it will show, hey, I want to be a worker node, similarly to the command that you just saw, or basically exactly what you just saw, where we just have the docker run command with the -- worker on the end. it will register itself as a node to the cluster. Then it will wait for etcd and control plane nodes to be fully provisioned, right? So it won't do anything until etcd and control plane nodes are fully configured or provisioned in the cluster, because it can't do anything without it. Because if a worker node gets provisioned and it's done, and the kubelet starts and it wants to register to Kube API server, which lives on a control plane node, it can't connect to that control plane node, right? Because it's not up yet. So we firstly provision the main components of the cluster, that's etcd and the control plane node, like the core, which need to be functioning, and then we can add worker nodes, and those worker nodes will wait till the cluster is ready, fully provisioned, and then they will go into their cycle of getting into the cluster, and that is described in this bullet. So what they do is they request something that's called a node config, and the node config is basically a configuration, and it's a JSON configuration which Rancher will generate. It will use RKE under the hood for that. So that means Rancher serves on a certain endpoint. So it's a web server. It serves on a certain endpoint, and the node will request to that endpoint to say, hey, I'm a worker node with this name and this token, etc. I'm a worker. Give me my node config, and the node config describes exactly what that node needs to be part of the Kubernetes cluster. Basically, what is said in the last line is everything in that node config is included, which is needed to run. So that means it includes all the components, so all the Docker configuration that is needed to add that node to the cluster, configurations of flags and parameters, etc. But also files. So, for instance, if you have a custom cloud config, or you have or certificates, because certificates are always needed, that will be requested, and the worker will process that on its own, right? So the agent will run on that node. It will request a node config. That node config gets parsed, and then we translate that to components on the node. So to visualize that, I will also show this command because this command, I like to make commands that are generic, so that don't people have to like copy paste things and then change node names, etc. So this command basically does that request, right? So let me just make it a little bigger. So the endpoint is, for people that can see, is version 3 API version 3 connect config. So that's the endpoint that is used. And if we request that, then you can actually see, so it's JSON. You can see for this cluster name, we see the certificates that are needed to be provisioned, right, to connect to the cluster. But also, if people see this, they probably recognize like the Docker kind of inspect output, right? So if you see the kubelet, it says, hey, this name is kubelet. This is the command that we need to run. We need this image. So this image is, so to emphasize, this configuration is created on the Rancher side, and that's still created from the RKE side, right? So this is normally in the provisioning process, this is the plan that RKE executes against the node. But in this case, because workers are treated differently in Rancher, this is the JSON that it requests. It's generated on the Rancher side based on the cluster configuration and everything that Rancher knows about that cluster, and sends it back to the node. And this node will then run this command. Every container is in here. So I had another a view where we see like, okay, kube proxy, kubelet. So this is a worker. So we have kube proxy, kubelet, an Nginx proxy, and a shaman container, and a server sidekick. So this server sidekick was also mentioned by Hussein. But this is basically the node config / the plan that makes workers work, to say it like that. So workers will request that node config and run it. So the other reason why I'm saying that is that some people get confused about how workers are shown in the UI. Sometimes it looks like, if they're stuck like this. We are in newer versions, we are changing that the provisioning state will not include workers, but we will show the worker state, right? So the provisioning state of the workers will be shown in the UI, where it will say, hey, this is the state of this worker and what it's doing, versus just waiting to register. Because this is a kind of like, it should be okay, but if it never goes past registering, then you will never know what's going on, right? Like, is it doing anything? Is it, etc. So we are improving that to include the status of workers provisioning into the UI, so you can properly see, hey, this worker node is now busy with upgrading to the latest version, or whatever you set it to be. But at least you get some more feedback on that. But that's good to know that, first of all, that they're treated differently, and then how they are treated differently, right? So if you want to debug anything, or you want to see, hey, I configured this cluster this way, but my Docker container does not have this configuration, what's going on? You at least know where the configuration is set in Rancher, so I showed you that. And the other thing is like how you can debug what that node config consists of, and is it actually applying it wrong, or is it actually being sent wrong by Rancher? So that's another go-to there. Okay, so that's executed by the agent. Agent requests node config, node config gets parsed, and then gets executed by the worker. All right. Okay, last thing, last slide, I promise. etcd snapshot. So what I said before is that when you run RKE up or using the RKE CLI against nodes, you get an etcd running snapshot container based on the configuration that is defined in the cluster.yaml. And that is because, like I said before, there's no central component in RKE where we can say, hey, we have this always running RKE daemon or something that can trigger backups, right? We need to have something running in the cluster to make sure that the backups are run. And that is a etcd running snapshot container. In case of Rancher, we actually give you a UI, and we give you management etcd snapshots by making them available in the UI. You can delete them, you can trigger snapshots on the UI, etc. And to make that happen, we need interaction between Rancher and RKE. So again, we have this etcd backup controller. We're back into the controllers where we can say, hey, we have resources that we can watch, we can act upon. We can have the etcd backup configuration in Rancher, where we can say, hey, I want to have hourly snapshots to or local or S3 or I think actually that those are the two only options at this time, but you can configure where you want to store them, and then what interval, and then like I said, we give you the option to browse your snapshots in the UI, etc., and delete them there, etc. Those are all things that we don't have in RKE. But again, if you want to look or find out how that works, we have an etcd backup controller. Again, we use a controller for that to watch state and act upon that. That also gives us an option to run that at least compare. The controller runs is like I said, is a control loop. We have a configuration for the etcd backups. It will check if that configuration is met, or is hit. That needs to run that, and it will trigger a new snapshot. I think I thought of something while I was talking about this. I think that's it. So, and then again, this link. So this controller, if you go into this code, etcdbackup.co, you will actually see references in there to functions. Again, the functions in RKE that will call, a save snapshot, for instance, where we will call, hey, I'm going to run a snapshot for you. That's basically the same exact function that you get if you run it on the CLI, right? But because it's in Rancher, we need to, first of all, it needs to be in a controller because we need to be able to run it in a recurring fashion, or we need to keep track of it. Like I said, we need to store it somewhere, so we need to know what backup snapshots are available. But basically, the core logic of making snapshots is the same in Rancher because we use the same function call that RKE provides, right? So we use that function from RKE in Rancher. It's just that we need some additional information, and also we have that component that can contain state and can actually trigger certain actions which we don't have in RKE. All right, that's it for the material. So before I'm going to answer the questions, because usually after questions I always forget to say this. So anything said in this, I mean, all of this is recorded and will be placed somewhere. The slides will be available. But if you have any questions, and I think this counts for us, Hussein, too, is that if you have any questions about the material or anything that you run into using the product or even developing the product, because I mean, if you're a user and you don't want to dive into code, that's fine. But if something breaks, it's a bug. I mean, if you get into some crash or whatever, that's a bug, and And we are very happy if you report it to us so we can look into it. But also if you look in the code and say, hey, I'm seeing this weird behavior and I'm looking into your reference code and I think this logic is wrong, or I think this is causing my issue, you know, ping us. We have a developer channel in Slack. Hussein is on Slack. I'm on Slack. You know, find us. Let us know what you hit or what you've seen, and then we can look into it. And we can, I mean, finding an issue on GitHub is always good. I mean, we're also looking on that. So anyway, what I'm saying, what I want to make sure that you know is that just let us know if you run into anything or think you run into a bug. So okay. So that's the material. Let me just go to a few questions. Let's see. If three etcd nodes are deployed, if one terminates and gets up, data is rebuilt or etcd use permanent volume. Thank you. Well, so I mean that's basically in like one sentence. That's a lot of a lot of options. So three etcd nodes. It gives you one failure toleration to call it like that. So you can lose one node. So it's a quorum-based system where you need the majority. So two of the etcd nodes need to keep running. If one gets terminated, so that's a bit of a question, like terminates like a reboot, for instance, that will just come out fine. That I don't see an issue with that. If you say terminate and replace, you can either in RKE you can edit the cluster.yaml, remove the node, run RKE up to make sure it's removed, and then add a new node and run RKE up, and it will edit. You know, it will add a new node to the cluster, and you will have three again, and those will then sync the data between them. So that's fine. The permanent volume is then where the etcd data is stored, and by default that is a host volume, right? So the data is not in the container on the container file system, but it's on the host file system. So it's also stored there. Not also, but it's using that as storage for the etcd data. So I hope that that answers your question. Yeah, so this is also, I'm going to pick this out because I've seen this many times. So why is there no option in Rancher to create a cluster on Google VMs, similar to EC2? I know GKE is possible. Right, so GKE is, I mean, that's, so because Container Engine is a Golang, a tool written in Golang, we use Golang libraries to interact with all those clusters, right? So if we talk to GKE or AKS or EKS, they all have Golang libraries, and we use them, and we use those functions to make sure that the provisioning works. Google VMs, the last thing that I've looked this up like recently, is that the authentication of Google was troublesome, and that meaning that it needed I think it needed external authentication method to interact with clusters, and you couldn't just give an access key and a secret key, like for instance AWS. But I'm not really sure if that's still valid today. So the reason was that there was no way to provide a static set of credentials, like I said, an access key and a secret key, to get machines and then act upon them. And the second thing was something regarding SSH. But anyway, there is an open issue for it. You can look it up, and please upvote it using the emojis, not by commenting, but just using the thumbs up emoji on the main issue, so we can see that there is interest in that, so we can make that happen. Let's see. Is it suggested to pin each RKE node in an HA Rancher installed to different hosts in the VM cluster? So it's just to pin each RKE node. Okay, so let me answer this question in the way that I can that I interpret it, and I think that also makes sense for other people. Is that if you go into the documentation of Rancher, we have actually we have a best practice guide, and we have a production ready cluster documentation. So if you look for either of those terms, you will get into the best practice and production ready cluster, and those will describe how you can set up or design your clusters in a production ready fashion, right? So HA, fault tolerant, and we'll make sure that all the components that are vital to your cluster are or will remain available. So, for instance, what we just discussed with etcd, you need 3 etcd nodes at least to survive one failure. A common issue with etcd is that people will say, okay, I will just save one node and I will do 2 nodes, and that actually makes it worse, because if you lose that one node, it will crash your cluster. While if you have one etcd node, that will, I mean, there's no, what I'm trying to say is that there's no added availability by adding a second node, because the second node will crash your cluster, one node will crash your cluster. So there's nothing to gain there. Please use 3. The control plane node obviously needs to be at least 2, because those components need to be available, etc. All those things are available on those pages, so I would suggest to read them there. The other thing is the HA install of Rancher, which currently is based on RKE. So RKE is used, for people who are not familiar with Rancher HA. Rancher HA is set up using the RKE CLI, 3 nodes, and all those 3 nodes have all 3 roles. So that's the etcd, the control plane, and the worker node. All those 3 roles are on each of those 3 nodes. So you have 3 nodes, and all 3 nodes have every role. And based on that configuration, you build a cluster. So you configure the cluster to YAML with those 3 nodes. You give them all roles, and then you run RKE up, and then you have a 3-node cluster with all roles, obviously, which is not how you commonly design clusters. But the exception here is that Rancher HA is only meant to run Rancher and nothing else. So that means we can run, there's no, if you want the easiest way to run an HA cluster, you can use RKE with 3 nodes with all roles, and then install Rancher on them, and then that's it. So Rancher HA is running on the cluster and nothing else, and then it's fine to mix roles. But I would say in a production ready setup, it's suggested to at least separate workers so that they can't overload your vital components, and those are etcd and control plane. So that's what I would suggest. You can do it if you're, what I always say, if you really know your Kubernetes, then you obviously can place limits on all the resources, and then it should never bring down the vital components. But even then, even if you know what you're doing, I would always suggest to split them, because those are the vital components of your cluster, and you want to keep them running at all times and not be interrupted by any thing that could land on a worker, like workloads or whatever. Okay, so we just say the worker nodes need to be always in a different node pool than etcd. Okay, so that's I just answered. And let me end with this final questions before I let Matthew wrap this one up. How mature is integration with vSphere? I know this is a commonly asked question, or at least a lot of people have vSphere. So okay, so first of all, basically the integration with vSphere was actually revamped in the latest. I have to double check this. In the latest release, where we improved the Docker machine that we use to interact with those infrastructure providers to get nodes, was improved to interact with vSphere. This is still in the development, so it is out. You can use it, but we're still actively improving it. I would suggest using that latest version and see if you can use that in your situation. If not, you can either, like I said before, file a GitHub issue with what you're running into, or you can join the Rancher Slack, and that's slack.rancher.io, like Matthew mentioned before. And then we have a vSphere channel, and in that vSphere channel are most of the vSphere users, and they interact with each other, helping each other out. But also we have the people working on that improved vSphere integration in there, where you can ask questions, or where you can discuss what you're running into, like I try to configure this and then I get this error or something like that, which will also help us improve the product, because we can only it will only make the product better if you have your experience. Hey, this is even if the docs are incomplete or not describing what you want, we can improve the docs, but we can also obviously improve the product to make sure it works out of the box or without docs, or something like that. So And that, I mean, basically what I just said at the end, it counts for all questions that anyone in the chat has. So I think, I'm not really sure, I think the forums also haven't been mentioned. So another medium that you can use is the forums. You can ask questions there, which is actively monitored by us. I think that's all for now. So I'm not sure if you're still here, Matthew.
Yes. Thank you so much, Sebastiaan. Yeah, that was great. So again, I do see there are, a handful more questions coming in, but I do think we should stop there. It's 2 hours, pretty darn good. And as we mentioned, this session was recorded, so we will send you all the recording and the slides. Look for that in your email, hopefully later today, more likely tomorrow. And we'll post it on YouTube as well, along with the Q&A. So there's been just fantastic questions that have been asked, and Hussein and Sebastiaan, answered many of them in the chat itself. So we will post that too, so you guys can review if you need to. And for those who still have just a couple questions here and there, or you missed your question, you can go ahead and ask it on Slack or the forums, as Sebastiaan mentioned. So one more time, that is slack.rancher.io and forums.rancher.com. A lot of open source users are on there, and engineers as well, who can ask questions. And then lastly, there were quite a few questions on just basics and fundamentals with Kubernetes and with Rancher. And I mentioned to some people, but so that everybody knows, we do have a weekly free intro to Kubernetes and Rancher online training. It's every Thursday, 1 p.m. US Eastern. And so you can go to rancher.com/training and sign up for that as many times as you want. And it's a little bit more intimate, a little smaller, less than several hundred people, so that you can get your questions answered there too. So with that, I think we will end. Hussein and Sebastiaan, awesome job. Thank you so much for putting all that content together, answering all these questions. I really appreciate it. So thank you for your time.
Thank you.
No problem.
All right, everybody, have a great week. Talk to y'all soon.